And yes, so as I was saying, I'm going to show I'm going to repeat this for the recording. I'm going to show a couple of example files, but this session is scheduled to be an hour long, but we'll need less than that because the examples are quite simple. And it's going to be about a bit more of troubleshooting for anyone that can't make this work. So yeah, if you can open the example file, any example file that is in the repository, I mean the RDF prototypes repository, which is the one you can see here. So if you go in the repo, there is a folder called Grasshopper examples, and you can download the examples just going, clicking here and downloading them, the single files, or you can decide to clone the entire repo, which is also a good option. If you have GitHub desktop or if you are familiar with Git, you can just click on code and do open with GitHub desktop to clone it, and it's gonna download the entire folder on your machine. But anyway, what you need now are just the examples, which are in this folder. So if you can download them, we're gonna look at them. The first one we're gonna look at is this one here, custom class generation with custom object. So yeah, just open that. I'm gonna copy the link in the chat just for everyone to make sure that, yeah. Cool. Yeah, make sure that the file is unblocked. If it is, like, sometimes I've heard people with the problem, they have the problem of Windows blocking the file. So if you right click on the file after you downloaded it and you check that the properties, within the properties, the file is unblocked, yeah, make sure of that. Yes, so, well, after you've opened Rhino, sorry, I want to take this away. After you open Rhino, you should see BHom here, if the installation process went well from yesterday. And you should also open the file, that file I just mentioned, and it should appear like this. If you have any error here, it's because you've missed one of the steps. You should add here in this input the root path where your Git repository of BHom is located, and it's gonna be basically I'm gonna open the instructions again. It's gonna be basically the one from step 6. Sorry, yes. Oh. The one from step 6, the one with basically where you downloaded this repository here, BHom. Yes, so basically I have it here on my machine. I'm gonna show you where it is. It's yeah. So you see I have a GitHub folder. I have plenty of repositories in here, and the BHom repo is here. Sorry, I can hear someone speaking. Is it a question or?
Fatima, I guess we cannot hear properly. You can type your question if you want.
I think you should probably unmuted her by mistake.
Yeah, I just muted, but if it's a question, please type it.
Yeah. Anyway, yeah, so this is where I keep my BHom repository. And if you go one folder up from here, you see this is the GitHub folder where I keep all my repositories. And, it doesn't matter. I mean, it's just the folder that stores the BHom repository. And you need to copy this file path and place it in a panel and input this into Git root path here. And if you had an error here, then the error should disappear after you've done this. Cool, yes. So let's look at this. Essentially, it's very simple, the script. You have a main component here, which is the one that does the conversion. And you have other few components before it. So essentially, these components here are about settings. You can think of them as advanced things you don't need to care about right now. You can do some things, some advanced options with these. And then you have the iObjects input, which is where you put the objects that you want to convert to an ontological format. So this is a key component that you will need for this workshop. And it's the component that transforms BHom objects into an ontological format. We adopted TTL as an ontological format. TTL is turtle, and it's a format in which you can write ontologies. And TTL is, and correct me if I'm wrong here, Dielsa, is built on top of RDF, and it's also using all. So yeah, it's basically an ensemble of different, syntaxes that we can use to describe an ontology. And yeah, we adopted it because it's quite simple and readable from humans as well. So let's maybe have a look at this right now. So what we're doing here, very simply is, well, we have a BHom object, and we will go through this BHom object later, but we have an object, and this object here has, it has a certain type. It has a property called list of numbers, and this property has 10 numbers from 0 to 9. And then there is another property of this object, which is called a list of points, and this is populated with 3 points. And yeah, so the object that you get here, it's some object that contains these things, and we want to convert it to an ontology, and that's how you do it, using this component, and you get a file, a textual file describing the turtle ontology out of it. So let's look at the format, the full thing. It's a bit long, but actually you don't need to read it through all of it. It's just, for you to understand how it's composed, the ontological format. And, I'm talking and mentioning many things. If anything is not clear at any point in time, stop me and, just ask the question. Anyway, the turtle format here is made by a starter section, which is called header. And in this header, we store some prefixes, and you don't need to know what they are, but they are essentially things that are useful for the ontology. And yeah, so they are basically always the same, independent of what objects you use. Then you have some more kind of utility things, annotation properties. They are always kind of the same, regardless whatever objects you input. And then you start having the things which are dependent on the objects that you are using. So yeah, the first thing is data types. This section here is related to what kind of data types are present in your ontology. And it depends on data types it's a concept from ontology. It's basically every type that is not an ontology class, essentially. An ontology class, we're gonna see it now. It's down here. It's another section. An ontology class is essentially anything that can be mapped to a class in the ontology, and a class in the ontology is essentially something that can be used to describe a concept in the ontology. And again, Dielsa, correct me if I'm wrong in anything I'm saying here. I'm trying to keep things simple, and also I'm not super knowledgeable all these topics, but that's my understanding of them. And essentially, so go ahead.
Yeah, yes. I think it's correct so far, but anyone from the audience, if you have questions, please jump in and ask, because it's better to have as a discussion. I guess it's clear right now, at least for the ones who are familiar with ontologies, that you have the ontology and then you have the actual data. And what we are doing here in this ontology generation, we are generating a new ontology based on the data that we define. So the classes, actually, we are defining classes of an ontology. We are directly creating the ontology and the data, like the T box and A box, directly in this graph.
Yes. So to get a bit more technical, yes. So we have an ontology is made of a T box and of an A box, which are fancy terms for saying something quite simple, to be honest. As I like to think about it, the T box is sort of like a description of what you will have in the ontology, of what objects you will find there. And then there is the A box that actually tells you what are the objects present in the ontology. It's sort of like, if you're familiar with programming, it's sort of like a schema versus instances. But yeah, you know, if you want to describe it then more, the Elsa, you know, please feel free. But it's simple to me. It's like, it's just that sometimes we use these fancy terms like A box and T box, and people are not that familiar with them. But it's quite simple, I think. Yeah.
Yeah, and this format here that you can see, it's human readable, but at the same time, you can just take it, import it in some graph visualizers, and you can see your whole graph of data. So it's just a text. It's not just a text that we don't do anything with it. It's like a live data storage represented in a graph at the same time.
Yeah. Yes, because an ontology is a graph. Anyway, it's a representation of a graph. I see there is a hands raised as well. So maybe if you want to.
Yeah, I just have a quick question. The classes that you instantiate here in your graph, are they the classes that are necessary for the objects that you have, or are they all the classes that you have in your ontology?
No, it's only those necessary to represent the objects that have been input.
Okay, great. Thank you.
Perfect. Yeah. So yeah, that's a good question. Like we did, for example, at some point at early stage, we took an approach where we were mapping the entirety of BHom into the T box, basically translating the entirety of BHom to classes in the ontology. But we changed that approach, and yeah, it's only what you input from the objects.
But maybe just to clarify for Navid, so we can see that the input class right now was something. Can I see the input class? The
so the
room or custom
object.
object.
Yeah, here.
Yeah, the input object. Actually, we are customizing it. We just define the type.
Yeah, sorry. I didn't cover this yet, but yeah, let's go through that. I just wanted to before we go to the
structure. Okay.
I wanted to check the structure. Yes, sorry. And Fatima, I'll take your question in a second. Sorry, let me just finish going through the entire file. So otherwise we open too many doors, I think. So the classes are essentially what we said. It's basically there are things, there are ways to describe what is present in the ontology. And then there are object properties, which are the properties of the classes. So for example, we can see that the object here has list of numbers and list of points as properties. And so you will see that there is an object property, list of numbers and list of points here. It's a bit more complex than this, how they get translated to exactly this, but you can think of, the properties on object become object properties here. There are also data properties, which are still properties. So object properties and data properties are both properties of the objects. It's just that the data properties are basically a group of properties that include types that are not ontology classes, but data types. And data types in general are simple things, like we call them primitives in certain cases, and which are numbers or text strings. And yeah, mostly those two things, like numbers and strings. Numbers can take different forms, as in programming. So they can be doubles, or they can be integers, or they can be other things. But yeah, for example, an XSD double is a way to say that this data type is a number of, it's a specific type of number. It's a double. And yeah, you don't need to know what a double is, but if you're familiar with programming, is something very specific. It means generally a number with a comma, like it's a fractional number, whereas an integer, it represents an integer. So you will also see XSD integer if the number is just an integer. And yeah, we'll go better through these things later, but just to say, last section is the individuals. And the individuals represent every instance, every object instance in the ontology. So essentially everything up to the individuals section is what we call normally T box. And everything down here is, you can think of it as the A box. It's essentially up above this line, above the individuals, you can think of things like as a schema to represent the ontology. And then individuals is like the instances of the schema. Again, making a similarity with programming. Yes, so the individuals here, you can see, for example, that we have an instance of this thing called some custom type, which is, yeah, this object here, which is called some custom type. And this object here has, you can see it points, it gives you like, there is two properties. One is list of numbers and list of points. And this is not a description of the property, because the description of the property is given above in the T box in the section object properties. What this gives you is the actual content of the property. So it gives you the numbers like 0, 1, 2, 3, up to 9 for the list of numbers. And it gives you the content of the list of points as well. The content of the list of points is a bit more complicated to write in the format here, but it's actually still very simple once you've read across it. Essentially, the list of points is simply a list of pointers, of links to what the points are actually are. So, for example, you see here, list of points is a sequence where the first element 0, is located at this address. And if you go at this address, which is, all this long thing with this number, you go basically at this line here, you see what the point is. So you see that the point is, contains 3 coordinates, X, Y, Z, and these are the coordinates. And then the next point in the list is going to be the one at number 1. And it's, located at this address. So you go here and you see the content of the point. We do this because this is the ontological way to represent instances, objects. It's just a conforming way. And again, it's a bunch of links. The ontology in the end is like, it's just a bunch of links, or in other words, it's simply a graph. So it's just nodes connected to other nodes via some arrows. And yeah, so that's basically what this whole format represents. So yes, we will go through the objects as the next thing, but Fatima had a question. So I'll answer that, and I'll take any other questions up to this point here. Fatima, if you want to go.
Yeah, thank you. So this is how we create ontologies within BHom. We were discussing, there are other ontologies like bot and others. Are we going to discuss those as well? Like how we can bring those ontologies, and we can use and maybe combine different ontologies within BHom?
Yeah, if I can take this question, Alessio.
Yeah. Yeah.
Yes, just after Alessio presents what you can do right now with BHom, afterwards I will show how you can align existing ontologies with your custom ontology.
Okay, thank you so much.
Perfect. Any other question on this part here? I know it's quite a lot of things, but actually I'm also happy to repeat anything or go in more details on anything of these. It can look complex and overly complicated for some reason, like for some people, but I mean, it did look like that for me at the start. But actually, if you just grasp a few things here and there, it's actually quite simple. Anyone speaking? I think I hear something. No?
Yeah, can you hear me?
Very low. Very quiet. Yeah, a bit better. It's a bit noisy, but yeah, go ahead.
Okay, I was saying that, can you talk a little about the ontology?
Yeah,
sorry, you're breaking up. Sorry, we couldn't hear you.
Maybe you can type your question.
Maybe you can type, yeah. Yeah, in the meantime, if anyone else has a question, we can can answer. I talk about the ontology in construction. I mean the existing ones.
Yeah, I will show right now some examples, but actually right now this is to have some self-made ontologies, because as we were discussing yesterday, there is sometimes a need that you want to define your own objects and create the ontology from your own objects. That is the way how you can create the ontology from your own objects. But maybe Alessio can go through the presentation how you can use this tool to create your own custom ontology.
Yep.
And then I will show how you can connect it with some existing ontologies by creating some alignment modules.
Yes, so the purpose now is to show you how you can use this tool in BHom to create your custom sort of ontology right now. So yeah, definitely we can later discuss the rest. Cool. Yes, so as we've seen now, this is a tool that translates objects in BHom to an ontology. Now, we have, as I mentioned yesterday, we have a bunch of objects in BHom that are related to different disciplines and areas of expertise, etc., etc. Right now, we are not using any of them. We are doing a custom object, which is something that you can do on the fly to represent whatever concept you want without needing to write a class in C# for BHom or stuff like that. So that's what we are doing here. I'm going to make an example just to contrast these with, standard BHom objects and, better explain what we're doing and what you can do. So in BHom, if you go in the OM section here at the tab, you can create an object by selecting these. And if you drop this component becomes like this, create object. You can right click on it and do select an item. And then you see you have the choice of, many different specialist namespace, essentially. So these are all categories of special domains. You can see there is geometry, which has a bunch of things, a bunch of geometrical shapes. You can see there is architecture. You can see there is structure, etc. I'm a structural engineer, so I'm going to make a quick example with one of those. So, for example, if you look at let's elements, and then you take a bar, which is this guy here. You take, you can feel free to choose whatever you want. It doesn't matter. It's just an object. So this is an object in BHom that represents a bar. If you don't remember where one thing is, you can still type in the search bar. This is just a quick reminder. You can use Control-Shift-B to pull up a search bar. So shortcut is, I'm going to write it for everyone. It's Control-Shift-B. And if you do that, you pull up this search bar, and you can search the term here. So I'm going to type bar here, and you can take one of these entries. You can see there is different icons for different things. What you're looking for is this icon here for objects. This first entry is related to type. It's not what you want. So if you select any of those things here, you will get the component to create the object. And you can see the component to create the object takes a start node, end node, section properties. These are all things that describe what a bar is. And a bar for structural engineers is essentially an element, like a line element that describes a beam or a column. And can be used for structural analysis. So this bar here, I'm not going to do anything with it. I'm going to just leave it as the false for now, just to show you. You can insert this object here in the component TTL graph, and this will update the output here with all the properties of the bar. So it's going to be different from before. We will not go through it now. But essentially, that's simply it. So you will see that object properties are, for example, start node, end node, section properties, which are all the entries that you can find in here. and the instance is probably going to be quite empty. Yeah, the individuals is only one guy here. Well, it's pretty much empty because I haven't input much things in the bar. But yeah, so that's just a demonstration of how you would, you know, if you have a model taken from like a structural model in robot, and you pull, a robot is a structural software. It can be any other software that's compatible with BHom. So if you open a structural software and you have a model in that, and you want to pull the model from the software using BHom, you then get a BHom representation made of objects like a bar, a node, and stuff like that. So it will be a bunch of BHom objects. If you take those BHom objects representing that model in robot or the software, and you put and you attach them to the TTL graph, you will get an ontology for that model. So, and it will be effectively an ontology of the structural model coming from robot. Just, you know, this is just to give you an example. For the workshop, however, we're going to do something a bit simpler. So we're going to do essentially, well, you can even do whatever, even what I just mentioned. So I'm also happy to support you. And if you need, you know, if you want to try a workflow that like the one I just mentioned, but I'm going to show you here something simpler, which is like creating on the fly objects like the bar, which I just shown. So you can use the custom object here. You can go in OM again and do create custom, this one here. You drop it here on the canvas and you do right click. What is it? Sorry, not right click. So you zoom in and you do the plus symbol and you can start adding properties to it. And you know, this way you create a custom object, effectively something that it's an object, it's a BHom object with any property that you want. The key thing is that in order for these objects to be converted correctly as an ontological format, we need a property always. So I recommend you to always do as a first thing, do this, right click on the first input and change its name to, sorry, to type. So you need this property always to convert the custom object correctly. And you need to specify a certain type name for it. So say you're creating a roof object, you need to attach a name roof to this. So from now on, this object is going to be recognized as of type roof. That's simply a way to, you know, store the information about what type of object we should convert this guy to in the ontology. You can then add whatever properties you want. So I don't know, it can be tiles, like roof tiles. And then I don't know, material. Whatever you want, stuff like that. And so, for example, let's create another custom. Well, first thing, let's try and just input a few random things in here. So I don't know, I'll put a number in those two. So I get an object. It's a custom object, and we said it's type roof. If you want to check, you know, if you receive a bunch of objects from somebody else, or, you know, you just receive a bunch of custom objects. So say you have the data like this, which is containing custom objects, and you want to check what properties are in there, you can use the explode component here, engine explode. And if you attach this there, you can see, you know, it basically opens up everything that is contained in that object. You will find type, which is going to be roof. You will find roof tiles and material and values that are there. There is also a few extra properties. Don't worry about those, but basically the first properties that you will find are the ones you've used to define the object. Yeah, that's all the components you actually need to know. Remember, if you can't find a component, you can always use the search bar, Control-Shift-B, and you can type explode here. And that's it. It's a bit slow, sorry, on my machine. You can find the explode component. It's the one with the icon like this. Yeah, anyway. So that's how you create the object. Again, if you place this guy here, you will get the ontology out of it. You can also, for example, for roof tile and material, we have lots of materials defined in BHom, but you can also define your own material by doing another custom object. So you could, for example, do create custom again and do, I don't know, something, material name. Well, first of all, type, and then I will do this. So you could do, for example, type, it's called material, and the material name could be, I don't know, clay, something like that. And you could put it there. Yeah, and the same for roof tiles and for everything else. If you have a list of things that you want to insert in a specific property, you need to remember one thing. So say that you want to specify, what could that be? Could be an example with a roof. I don't know, say that the roof has multiple materials, sorry. Say that you have, I don't know, a material for something, you know, could be a mixed roof of wood and something else. So let's do like this. So in this case here, what you want to say is that this roof object has two materials, the same object. Sorry, I'll put something, I'll remove this property. Yeah, so if you just do this, you see that the output changes, and this becomes an output, you know, you see the wire also changes, because this is actually a list of two custom objects. And this is happening because you haven't told the component that this input here is actually a list of inputs. So you can right click on the input and do list access. And if you do that, you see the wire changes again. It becomes a single wire. So it becomes again one custom object with two materials entries here. So you can check again with the explode, for example, and you see that the output materials has got two materials in there. You know, by doing this, yeah, sorry, I'll just finish this. By doing this, you basically can, again, convert the object, and you see that in the individuals, for example, if you go down, yeah, you basically have the materials, which is a list of materials. So you see that, yeah, there are materials, it's a sequence with two entries, just to show you that. Sorry, yeah, there was a question.
Yeah. Alessio, could you also show as input a mesh, a geometry constructed from points? So we have a list of points.
Yep.
That creates a BHom mesh, and how the geometries from Rhino, like the points in this case, can be directly translated to primitive data type.
Yep, let's do that. So say that you have an entry which is, you know, roof shape, I don't know, shape, and that you want that to be a mesh. So
yeah, mesh from points.
Yep. Maybe let's do that in here. So I'll do some points. Sorry, I lost my search bar. I'll place some random points here, and I'll use them to define a mesh. Can't even remember anymore how to do that.
You can also just use the mesh from BHom. Okay.
Yes, sir. Yeah, just did this. Sorry, I did a random mesh.
Yeah, it also works.
Yeah. So this is a mesh, and we want to use it as an entry. I think we need to convert it to BHom as the first thing. Sorry. So my computer is super slow because I'm presenting as well. There we go. Okay, so just testing this first. There you go. That should have worked. Yeah.
And you see the points.
So basically what I've done here is I've created a Rhino mesh, you know, whatever mesh you want. And then you can convert the mesh to BHom using the from Rhino method. I looked to it because I remembered how it was called, but essentially, I think, let me see if it works. What happens if I do this? Actually, don't know. Oh, wow, nice. Okay,
Yeah,
works
it
anyway.
recognizes.
Even easier.
Yeah.
You don't even need to convert it, it's done in the backend for you, so you don't need to do it manually. But yeah, sorry, I didn't remember if it worked anyway. But yeah, this is a method that converts a Rhino mesh into BHom mesh. Apparently, you don't need it for the workshop, so you can just convert, plug in your mesh to the object, and you will see the points here.
And whatever Rhino geometry.
Whatever Rhino geometry you have, yes. There might be some limitations, but anyway, there is a conversion step between Rhino geometry and BHom geometry that will happen in the backend. And we support basically almost like 95% of geometries. There is some limitations though, like if you have some conversions error or stuff like that, you know, let me know. Some things are quite difficult to convert from Rhino, but yeah, it should work for most cases. Cool. Yeah, no problem. I see people thanking me, so no, yeah, absolutely no problem. Again, if you have questions, yeah, you know, just shoot. This is mostly what I wanted to show. I mean, there is another example file which you know may not need for this workshop. I mean, and we can open it, but you know, I want to keep here for people to ask questions. If you have any question for now, maybe yeah, just give me a thumbs up if you want. Where you find the From Rhino button? I can't find it. Yes, sorry, the From Rhino button is not a button, it's a method. As I was saying yesterday, basically BHom, you know, you see if you go in the BHom tab, you can find just a few buttons. It's probably, I don't know, 12 of them. I don't know how many is that, 20. The point is in BHom you can find, I don't know, thousands of things. So there is not a button for every one of them. And you basically can search in because the tool From Rhino method, it's called From Rhino, it's a method. It means it's an engine thing. So it's where every other method is. So you can drop a convert engine component, or you just look in the search bar, which is what I like to do. So if you, sorry, I'm going to copy this because it's faster. So if you open the search bar with Control-Shift-B and you type in From Rhino, you will see all the From Rhino methods that are available in BHom, and you will have to select the one for the mesh, basically, to convert it, which is the one here at the bottom. But it's not needed. Sorry, this is just to say that you don't need it.
Alessio,
Yep.
just this is part of the Rhino toolkit, right? So maybe it's not appearing if they just install BHom.
It should be in the installer. It should be in the installer. Doesn't it work for you guys? No, it's in the installer, I'm pretty sure, yeah. So yeah, if you install BHom, you should have this, yeah.
And I see another question from Zhenjiang. It works, perfect. I thought for me it didn't work at the beginning. But I see Zhenjiang asked what are the edges. So the nodes and the edges are actually the class. May I just?
Yeah, that's.
Annotate?
Yep.
And I don't know if I annotate. So now we have a custom object. This custom object is one node. And the type here, here you have another node. This is called roof. And here you have the instance, this custom object. You have, for example, roof 1. This is type RDF type. Beautiful. I don't know if you can see it. And then you have here the properties. So this has some properties. It has the material, it has, this is material, this is shape. Then you have the other objects. This object is the new material node, and this other object is the other material node. So basically these are edges, and this is the node. For example, in the room, can you do room again?
Yep. What do you mean by doing room again? Sorry.
Can you just create an object, room object?
The BHom object room.
Yes.
Okay. No. So if I create, can you remove the scribbles? Sorry, or do you want to keep them? Create object. So if you go in create object, and you, or even you can do the search bar again. Room. If you type room. Sorry, it's super slow. Yeah. You can see, yes, we have 2 ways of creating a room. If you read through the first words of each entry here, you see there is an acoustic room, which means it's a room definition done for specialists of the acoustic space. So yeah, if you want to define a room for what an acoustic engineer wants to think about room, you know, there's going to be some properties that you need to know. For an architect, you can go here in BHom architecture elements room, and this is the architectural definition of a room. So if we use this one here, let's try this. I'll click this. You see that an architectural definition of a room here in BHom is defined with a perimeter and a location. When you have an object in BHom, you can always hover over the properties with the mouse, and you see a definition of, you know, of what it is. So perimeters, it tells you that it's a BHom geometry I curve. So it means that you need a curve to define the perimeter. Yeah, blah, blah, blah. And then the location. And it tells you, it defines the dimensionless location in the 3-dimensional space. It can be anything for you, like it's a reference point for the room. So it could be, you know, say the centroid of the room in plan. So yeah, let's try and do, for example, a curve. And yeah, curve, we can do polyline. Sorry. Yeah, I'll do a random polyline here in Rhino. Tuck, tuck, tuck. That's going to be the perimeter of my room. Done. So I'll link it here. Set one curve. Internalize it just to be safe. So now there is a polyline, this curve thing, and I can input here in the perimeter. Yeah. So now the room has a polyline that defines its perimeter, and then you can, you know, attach it to this guy here. Yeah. So in this case here for the room, I think they also wanted to make an example. In this case, the room is a node. So it's a node on the graph. It's like an entity. It's got its own.
If I can just.
Yeah, go ahead.
Maybe I just screenshot this and I show both of them.
Yeah. Maybe it's yeah.
Can you give the name, my name? Can you write my name in a note, in a panel?
Yeah.
And just a point as a location. But now I will share briefly my screen. Just a second.
Yeah, so the answer will tell you now that essentially this is what are the edges and the nodes in this graph.
You see this graph here? I just try to make it quickly. So we have here the room. The room is this room. Then you have a perimeter, which is the property, and you have here a curve. And then this curve probably is described somehow. It can be 2 points, it can be something, it depends how you define it. And then you have a point as a location, and here is the location, this point, and then you have coordinate Z coordinate, blah, blah. Then you have the name. Name is data type, room name. This is how it looks like in a graph. Yes, how? Do you have a question?
Yeah, I have a question about this individuals, the information panel.
I stop sharing and Alessio shares.
Yep. Go ahead.
Same thing open.
I'll show your screen or.
I'm going to share my screen. Yeah.
Okay.
Can you guys see the screen?
Still loading.
You're not, but.
Sorry, I'm sharing the wrong one. Or
Anything is still Alessio has started sharing.
can you see the screen now, guys?
Still
No?
not.
Strange. I don't know what's going on. It's probably my machine, which is.
It is sharing. Yeah, we can
Okay.
see.
Okay, yeah,
just...
it's coming.
Sorry, it's very slow. Yep.
Can you go to the what's called TTL graph in the panels and in the individuals?
Yep.
I'm just trying to understand what actually it is there.
Mm-hmm.
If I understand it correctly, it saves information of these objects and decomposes it into its components and its components. It's like a chain of
recursive. Yeah.
Yeah, recursive. Yeah, right. And there's something that with a very long string.
Yes. Yeah, we can cover that. There are so
that, it's not here, but it
happens sometimes. Yeah. So that happens when there is no known conversion to TTL. So there are things that can't be converted correctly, let's say. So what happens is that we serialize, the technical term is serialize, the content into JSON, and then we encode it into base 64, again, a technical thing, but it's basically just a way to tell you that when a thing can't be converted correctly, we still store the data about that thing in the ontology, but it's just encrypted like a zip thing in the ontology. And you can't really read what's in there as a human, but the data is all there. So you can, read back from TTL. You can deconvert from TTL and get back the BHom objects correctly. It's just that there is no correct way or known way so far to convert correctly to TTL from the BHom or original format. It can happen when you have particular types in your input. Normally, if you keep things simple, it won't happen. But say you use dictionaries or data trees, then it may happen. And it can also happen, it can happen with strange types. I'm not sure. I can only think about data trees, dictionaries, things that are, I don't know, like we tried to cover all the basic types, basically, anyway.
And then it will be kind of encrypted and then decoded correctly on the web.
Yep. On the what, sorry?
On the web, on the...
They can be decoded from wherever you want to decode them. So essentially, there is a function that reads from. So I'm gonna show. I can show it here. It's called read TTL. So that's basically, this is the content of the second example file. So we're kind of going ahead, but it doesn't matter. So if you use the function called read TTL in the search bar, you can provide an input TTL text like that, and it will give you back the original objects in BHom. So you get a room. And if there was no, if there was a property that was encoded, you still get a room. Like if you, I don't know, let's try and, well, actually, let's do it. What can we do? Maybe I can't even think how to. What was the object that used to have some base 64? I think this guy here, maybe. Yeah. Let's try this guy.
We got one before with the mesh.
I think it was the mesh. Yeah, maybe the mesh in Rhino has some property that can't be translated correctly. So yeah, there you go. So sorry, that's custom data. What's this custom data about? I think it's just empty. Let me see. But
the encrypted thing, I think if you use a dictionary, you can see it. Ah, yeah, here.
Yeah, I can see there is something here. I'm just trying to guess what it could be. I don't, to be honest, know, because I can see that there are the points of the mesh anyway. So at some custom data is encrypted like that. Why? What's in custom data? I don't know. There could be something that is not translated correctly from the Rhino mesh. I can't think of what it could be. But yeah, so there is some information. There you go. There is also some problem here. Sequence contain. Yeah, sorry. There is something that may not work very well. Still work in progress. But the idea is that when you get this, it will be translated correctly. Maybe I can make another example where this works, because actually this conversion here will be mapped across to an object. Let me see what I can think of. Maybe I can do, I don't know, some C# thing. And how I will, sorry, it's still your hands raised. Sorry, I thought it was another question. Let me do something random. What could be, well, I'll do a dictionary, I think. Sorry, I'm trying to do a C# component, write a dictionary there and use it as a property, and which should take like 5 seconds to do on a normal computer, but my computer is completely frozen. But yeah, so I'm trying to demonstrate that. And if you do that, you will get an encrypted string for that entry, and it should work correctly. You should deconstruct that correctly. And I will, now that I discovered this problem with the mesh, I will try and debug it and update the toolkit to see, to fix this bug, because we constantly discover small things like this. Yeah, sorry, my machine is not cooperating, so everything
okay.
is.
I think I've already got your point. I don't want to destroy everything.
No, it's fine.
It's
it's just my machine is completely frozen.
Okay, and if you want, Alessio, you can stop sharing. I can show some examples what we can do with the workflow, with knowledge graphs in general, and then we can see how we can do it actually using BHom framework. I will share with everyone. Do you guys need a 5-minute break or not?
What time is it? Yeah.
It's 2. I would suggest we take just 5 minutes break and come back at 2:05 just to get a coffee and come back. I don't close the call here, and see you in 5 minutes. I will just share the link maybe so you can join the. I made it. You can also edit, but please don't edit until I am back. Wait. Send to everyone. I sent here a link. Can you check if it's working?
Guys, I will probably have the example that I was just trying to do later. So yeah, I'm doing it now. As long as as soon as my computer unfreezes, I will prepare it. But
then I see some people already joined, and I will go through these examples what we can do with what we can do during the workshop. But we meet in 5 minutes and we go through them together. Just to have the link here.
Yeah, Delta, sorry. Do you think you will need me for? Can I take a slightly longer break, like a 50 minutes break? Do you need me immediately, or?
I guess if you also see the examples, it would be better for everyone to know what they can ask.
Yeah, that's true. Okay, I'll try and make it a 5-minute break. Okay. See you later.